Hello, welcome back once again. Let us solve the equation c raised to the power of c is equal to 21. And we know obviously c is not equal to 0 and c is greater than 0 in this case. And we're going to solve this using the Newton's method. So let us first ln both sides of this equation. So we obtain the ln of c raised to the power of c is equal to the ln of 21. From here we get c ln of c is equal to ln of 21. Now let us define the following function of x as f of x is equal to x ln of x minus ln of 21. Here we replace c with x and that does not change anything. Now let us find the derivative of f. So f prime of x is going to be equal to, here if you use the product rule, here we get 1 plus ln of x, then minus the derivative of a constant is 0. So this is the derivative of this function, okay? And here we're going to consider the following points or outputs. So let us consider the following. So here f of 1 is going to give us 1 ln of 1 minus ln of 21, right? So this is obviously less than 0. So f of 2 here is going to give us 2 ln of 2 minus ln of 21. And this is roughly approximately equal to negative 1.66, which is obviously less than 0, right? Then here, f of 3 is equal to 3 ln of 3 minus ln of 21, approximately equal to 0.25, which is greater than 0, right? So we can see from here that 2 is less than x, and x is less than 3. And if you look, you will see that for f of 3, this is close, very close to 0, right? So we're going to take our first guess as x sub 0 is going to be equal to 2.8. So let's do that. Now, from Newton, we have that x of n plus 1 is equal to x of n minus f of x of n divided by f prime of x of n. So here, we're starting with this x0 to be 2.8. So here we're going to let n equal 0, then we obtain x sub 1 is equal to x of 0 minus f of x of 0 divided by f prime of x of 0. So this is equal to 2.8 minus. So here, this is going to give us 2.8 ln of 2.8 minus ln of 21. And then divided by here 1 plus ln of 2.8. From here, x sub 1 is approximately equal to 2.87961496. Okay, now if you let n equals 1, we get x sub 2 will be equal to x sub 1 minus f prime, or I mean f of x sub 1 divided by f prime of x sub 1. So when you compute this using this x sub 1 value, this right over here is approximately equal to 2.879070. Then if you let n equals 2, we get x sub 3 is equal to x sub 2 minus f of x sub 2, then divided by f prime of x sub 2. So this one right over here is approximately equal to 2.87907. And we can see that we have a repeated value here, as we can see, which obviously shows us that we have the level accuracy of the solution we need. Therefore, this right over here should be our solution. Then let's go back to the original equation. Our equation is c raised to the power of c, which is equal to 21. Then we can say that we have a solution. C is approximately equal to 2.87907. This right over here is our solution. Thank you for watching. If you enjoyed the video, kindly subscribe, also like, comment, and share.